All right, problem 1, if x to the fourth minus 3x squared y squared plus 4y squared equals 5, then the value of dy dx at 1, 2 is what? So dy dx is asking us to find the derivative. I do notice that we have some y's in the problem, so whenever we have a y in the problem, when we take the derivative, we will use dy dx. So let's go ahead and dig in. One thing I notice in this second expression here, we are going to have to use the product rule. So I'm going to let this be my f and this be my g, and I'm going to get it set up. My f prime will equal 6x, and my g prime will equal 2y dy dx. All right, so let's go ahead and start taking the derivative. The derivative of x to the fourth is 4x cubed, and then minus, notice I'm starting a parenthesis because it's going to be the product rule here, and it's minus times the whole thing. F prime g, so 6x times g, which will be y squared, and then plus f times g prime, so 3x squared times g prime is 2y dy dx, and then plus the derivative of 4y squared will be 8y dy dx, and then equals the derivative of 5 is 0. Okay, the next thing that I'm going to do is distribute that negative, so I'm going to have 4x cubed minus 6xy squared minus, I'm also going to put this 3 and the 2 together to make it 6, so I'll get 6x squared y dy dx plus 8y dy dx equals 0. Now I'm solving for dy dx, so anything that doesn't have a dy dx on it, I'm going to bring over to the other side. So I'm going to have negative 6x squared y dy dx plus 8y dy dx equals 6xy squared minus 4x cubed. Okay, the next thing I'm going to factor out a dy dx from the terms on the left. So I'll get negative 6x squared y plus 8y equals 6xy squared minus 4x cubed. And then the last thing is I'll divide by what's by the dy dx. So I'm going to get dy dx equals 6xy squared minus 4x cubed all over negative 6x squared y plus 8y. Okay, now it didn't just tell me to find the derivative, it told me to find the derivative at the point 1, 2. 1 is my x and y is my 2. So now I can go ahead and plug in what I know. So I'm going to have 6 times 1 times 2 squared minus 4 times 1 cubed all over negative 6 times 1 squared times 2 plus 8 times 2. Okay, so let's see. 2 squared is 4 times 1 is 4 times 6 is 24. So I'll get 24 minus 4 on the top. And then on the bottom, I'm going to get negative 12 plus 16. So that gives me 20 over 4, and 20 divided by 4 is 5. So my answer will be D. One thing, if I went through all these steps, I actually had to work the problem a couple times because I kept forgetting some things as I was simplifying. You could always, at this step right here, go ahead and plug in your x and your y values and then solve for dy dx if that saves you from making some math mistakes. Okay, problem 2. The graph of y equals f of x is shown above. Over what intervals is the derivative of f increasing? So it's not asking for where is f increasing, it's asking for where is f prime increasing. And I know that f prime will be increasing when f double prime is positive. Okay, well, how do I know from looking at f where f double prime is positive? Well, when f double prime is positive, that's talking about the concavity, and f double prime being positive means my graph will be concave up. So I'm just going to look over at this graph and look where is it concave up like a cup, and it's going to be in this little part right here, just from 2 to 4. So the only interval that the derivative of f of x is increasing is from 2 to 4. It's real important on this problem that you're just paying attention. It wasn't f increasing. We needed to really pay attention where it was the derivative of f is increasing. Okay, question 3. A truck moves with positive velocity from t equals 3 to t equals 15. The area under the graph of the velocity between 3 and 15 gives what? Okay, it says something about the area under the graph. I know that the area under the graph is an integral, and it says the integral is going to be from 3 to 15. So I'm going to put from 3 to 15, and it's the area under the graph of v. So I'll this is actually the problem that I'm looking for. So I need to figure out which one of these represents this problem. Well, I know that if I have distance traveled, that's kind of what it's looking like to me. When we have distance traveled, the formula is always a to b, the absolute value of velocity. So you'll notice these two are very similar. And one thing that it does tell us is that the truck is moving with positive velocity. So if the velocity is positive, I wouldn't need the absolute value symbols. So actually this does stand for a distance traveled. So it is going to be the distance traveled by the truck from t equals 3 to t equals 15. Another way that we could have looked at that was if I'm taking the integral of velocity, remember velocity would be probably like miles per hour, and if I'm taking the integral of miles per hour, it gets rid of the per hour, so I'd be left with miles, which is talking about how far something's traveling between 3 and 15. So that would be another way of figuring out that answer. Okay, problem 4. If f of x equals the integral from -10 to x squared of the square root of 1 plus t squared, then find f prime of 2. Okay, so this problem is asking me to find the derivative of an integral. So if I want the derivative of this integral, remember we know that if I'm taking the derivative of an integral, the derivative and the integral just cross each other out, and I'm going to replace this t with whatever is up here. It's the second fundamental theorem of calculus. So it's going to be x squared, and that quantity will be squared. But then I'm not done on this one, because since this wasn't just x squared, we do have to multiply by the derivative of x squared, which is 2x. So now I'm just going to clean it up a little bit. So I'll get the square root of 1 plus x to the 4th, still times 2x. And then they didn't just ask me to find the derivative, they asked me to find it at x equals 2. So now I'll just plug 2 in for all my x's. So now I'm going to get the square root of 1 plus 16 times 4, which gives me 4 square root of 17, which is choice E. Okay, question 5. On what interval is this function decreasing? Well, if a function is decreasing, I know that g prime will be negative. And in order to figure that out, we want to do a g prime chart. So I need to figure out where does g prime equal 0. So the first thing that I'm going to do is find g prime. The derivative, this is kind of like an e to the u problem. The derivative of e to the u is just e to the u. So it's going to be e to the x cubed minus 6x squared plus 8 times the derivative of u. And the derivative of u would be 3x squared minus 12x. Okay, once I've found the derivative, we will take the derivative and we'll set it equal to 0 to find the critical number. If you recall, an e raised to a power, this part right here will always be a positive value, so it will never equal 0, so I don't need to worry about it at all. So I'm just going to basically take this part and set it equal to 0, and I'm going to factor out a 3x, and if I do that, I'll get x minus 4. So my critical numbers would be 0 and 4. So the next thing that I'm going to do is go ahead and make myself a g prime chart. I'll put 0 on it and 4 on it. And again, I'm going to ignore the e part of the problem because I know that answer will always be positive. So if I plug, let's say, -1 into g prime, I will get a positive answer. If I plug 1 into g prime, I will get a negative answer. And if I plug 5 in, I will once again get a positive answer. So when it asks me for where is g decreasing, that would be where g prime is negative, which would be between 0 and 4. So B would be my choice for that one.